The Tiny Spectrum Analyzer is a portable tool which you can use to measure the output RF signal from any kind of RF source like local oscillators, PLLs or RF generators, and you can see how this RF signal looks like on the frequency spectrum. I am Paul, Oscar Mike Zero Echo Tango, and today I'm going to show you features and parameters of this Tiny Spectrum Analyzer. So let's get started. I bought this analyzer from Banggood and it costs around $50, and it is not a professional tool, so I don't even expect an extra high precision. But for our basic measurements, it is fine. Frequency range of this analyzer is from 50 kilohertz up to 350 megahertz, even if the label on the back side shows something different. There is a mention from 100 kilohertz to 350 megahertz. As you can see, there is also another range, 240 to 960 megahertz, but at this moment I didn't find why is it there. Maybe some sort of new firmware update requirement, or maybe they made also a different model. I don't know. There is an internal battery in it with charger, so you need just a supplied USB cable to charge it from computer's USB port, or power bank, or classic USB cell phone charger. By the way, this cable is also a data cable, not just a power cord. Inside the box we can find 30 centimeter long a small telescopic whip antenna with SMA male connector on the end. Two coaxial jumpers with SMA male connectors on both ends. And USB cable and some sort of stylus, which is really funny. The stylus on the cord, which looks like a guitar pick. Yeah, pretty neat. Okay. On the upper side of this spectrum analyzer, we can find a encoder with the button. Here we have a power switch and USB port. On the left side of this analyzer we can find two SMA sockets, which works like inputs or outputs. Depends on the configuration in the software of this analyzer. By the way, this is not a VNA or vector network analyzer, so you can't measure antennas or the SWR or bandpass filters, even if they looks very, very similar. So after power up this device with the power switch on top, we have to do a self-calibration first. So use one of supplied jumpers and connect this both SMA connectors on the side with this jumper. Okay. And now we have to go to menu. So just touch to the right side of the screen, and then we have to go to config. Like here, I have to use the pen. So we have to go to config, and we can push the self-test. The test is in progress now. You can see how the application is running. So self-test is complete. Touchscreen to continue. So just a touch of the screen, and now is the analyzer calibrated. So we can disconnect the jumper. Okay, and now we can make a new presets like 20 meter band, for example. So go to menu, switch the frequency again, and we can push the start button. We now set the beginning of the 20 meter band, 14.0 megahertz. So we have started with 14 megahertz, and we have to stop on 14.350. So again, touch the right side, frequency, stop frequency, and we type 14.350 megahertz. Okay, it's stored, and now we have full 20 meter band range set on the screen. The very good thing is to go to menu. We have to go back, and then we can set the preset. So go to preset, store button here, and store, let's say under this button, store 1. So now we can switch off this device and then back power on. This is default screen, so we can go just here on preset, push the load 1, and we are back on the 20 meter band. So now I'm going to use my RF source to show you how the output signal looks like on the spectrum scope, and I also want to find sensitivity of this tiny spectrum analyzer. So we have to use one of the 2 jumpers included in the box. I connected one side to the RF source and the other side to the low port on the left side of the antenna analyzer. Okay. The power source is turning on, and you can see how big signal appeared on the screen. So the signal is set on minus 70 dBm, which is more than S9. And now I will decrease the power from the RF source. I will attenuate the signal until the mark number 1 here on top will disappear in the background noise. So you can see how it falling down. It's still visible at 102 dBm, minus of course. I'm on 105, it's still there, 106, 107, and gone. It's gone now. So 108 is not visible. Yeah, it is there, but it's barely recognize the signal in the background noise. So I suppose that the sensitivity of this receiver is somewhere around minus 108 dBm, which could be a background noise of this equipment. So I go back on 70 dB. Okay, we are back. And now I will show you a display features. So when we go to menu and display, here we can find a waterfall, calc, and storage. So by pressing waterfall, the waterfall will appear on the bottom of the spectrum scope. It's very slow, not as the SDR receivers, but it is there. So press again on the right side, and now we can try the calc. This is a good feature if you would like to compare two similar signals, but the amplitude will be different. You can use, for example, max hold. Now we can see the maximum signal when we go to some different value, let's say weaker signal, 90 dB. It is not much visible now, but if I change the frequency, yes, you can see that this is a stored signal, and this is a new signal here. We can compare both signals by different power levels. So if you go back to display settings and go back to calc and off, peak is gone. You can select back to 070. Okay, so display settings, the next feature is storage. Now we can store trace, and we can move the frequency of the source and compare the signals with the same level but different frequency. So if we go back, and it's gone. So after display settings, we go back to the menu, and then we can select the marker settings. The marker settings means the mark here on top, for example, and you can search for any other options. So by pressing the mark, and here you can choose which one you want to find. Now it is search peak, so it searched the top level of the signal. If we go to minimum signal to the left, so this is the minimal signal minimum level of the signal. If you go back to maximum right, so go switch to this frequency, we are back here, or just pick search and it will be there also. Go back to menu. And now we can select the measure button, and this tiny spectrum analyzer offers many features what you can measure: harmonics, phase noise, signal noise reduction, signal noise ratio, and such more things. Like you can see the AM modulation, FM modulation, and so on. I'm not an expert with these things, so I don't even know what they means. Okay, when we go back to the menu, so the last thing is to go to config, and here we can calibrate the touch screen on this little analyzer. So if we touch the touch calibration, just have to select this feature. Now we can touch upper left, so I will try to touch as precisely as possible. So now is this screen calibrated, and we can also do a test. Just we can something draw on the display, and you can see that is calibrated okay. Okay, so press the button to finish. So the button would means this button here, just to press to finish, and we are back in the menu. Go back, and the next thing is the self-test. The self-test we did on the beginning. Level calibration, you have to use some calibrated device. I don't recommend to do these things with such kind of RF source like I have. So the other thing is the version. Here you can see the actual version what I have installed on my default. This is default version of this analyzer. And we have also the expert configurations. Also many things what you can to adjust, but I also don't recommend to play with the settings if you don't have a lot of skill with these things, and also a good tool for measurement and so on. And if you don't understand like me to these things what this analyzer offer. So next, more correct frequency, as you can see here, and so on. We can turn off the AGC, automatic gain control, and so on. Okay, so that's a lot of story about these features in the menu. Many of them I don't even know what they mean, for what purpose are they there, but anyway, I'm very happy to have this little thing at home. It's very helpful for my homemade equipment what I do, or maybe building receivers. This is a good thing to analyze the signal coming out from transceiver or similar things. Okay guys, so thank you very much for watching this video. If you enjoyed, please don't forget to subscribe to my channel and find the link where to buy this little tiny spectrum analyzer. You can find the link down in the video description. So thank you for watching. I wish you a very good day, and 73. Hope to see you again. Bye bye. Good luck.